Let's look at covalent bonds. Covalent bonds occur when one element isn't strong enough to pull an electron away from another element. So what they do is they sort of accomplish this by sharing. So covalent bonds share electrons. There's no taking. So if we look at our Lewis diagram, if we look at the periodic table to figure out the Lewis diagrams, we can determine how these things will bond. So hydrogen has 1, bromine has 7. So it'll be 1, 2, 3, 4, 5, 6, 7. So what happens is that when the two get together, this electron moves over to fill this extra space here. And what I'll do is I'll use another color just to show how that works. So we get H. So here are the electrons that come from the bromine. And here is the electron that comes from the hydrogen. So now, bromine has 8 electrons, it's happy, and hydrogen, which only requires 2, is also happy. Let's take a look at these guys. Chlorine is in column 17, so it has 7 electrons around it. Carbon is in column 14, so it has 4. So this electron fills in this space. So we get chlorine with 7, 1, 2, 3, 4, 5, 6, 7. But carbon has room to take in more electrons, so it can take another chlorine with its 7 electrons, 1, 2, 3, 4, 5, 6, 7. So it fills in to make 8 there. And it can take in another chlorine, 1, 2, 3, 4, 5, 6, 7. And another chlorine, 1, 2, 3, 4, 5, 6, 7. So now, if we look at the carbon, it's got 8 electrons around it. 1, 2, 3, 4, 5, 6, 7, 8. It's got a full shell. Chlorine has 8 electrons. You know, all the chlorines have 8 electrons around them. And so what this tells me is that we now have a formula of 1 carbon and 4 chlorides, whereas this one is HBr. Let's see, we'll take a look at this one here. Nitrogen is in column 15, so it's got 1, 2, 3, 4, 5 valence electrons. Hydrogen, we know, is a 1, so it's just got 1. But we can do the same thing that we did with the carbon. The nitrogen goes in the middle, 1, 2, 3, 4, 5, and now we take the hydrogens and fill them in. So H here with its electron, and H here with its electron. Now we look at the nitrogen, it's got 8 electrons around it. Each hydrogen has 2 electrons around it, which is what makes it happy. And so then its formula is going to be 1N, 3 H's. It's ammonia. Next one. Carbon and oxygen. Carbon, you know, has 4. Oxygen is in column 16, so it's got 6. 1, 2, 3, 4, 5, 6. And when they come together, carbon, 1, 2, 3, 4, and the oxygen, and we'll draw that in green so it's a little bit different, easier to see, has 1, 2, 3, 4, 5, 6. So it's got some sharing going on here. Can we take another oxygen? Yeah. It's got 6. 1, 2, 3, 4, 5, 6. Problem is, we got 7 here, and 7 here, and only 6 electrons around the carbon. So what happens is that these two guys move in. This guy moves down, and this guy moves up to put a double bond in here. And this guy moves in here, and this guy moves in here. So we got double bond here, and put a little brown one in there. Squeeze it in. So let's just draw it bigger. So we've got an O, a C, and an O with 4 electrons in there. So if we look around the carbon, we see it's got 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. And if we count the shared ones, each oxygen has 8 around it. 1, 2, 3, 4, 5, 6, 7, 8. Because these 4 go back and forth between the two. They're sharing those 4. Oxygen is 1, 2, 3, 4, 1, 2, 3, 4. So that's 8 altogether. And so this gives us a formula of CO2. Now, these compounds, one of them has more of the electron than the other. If we have 2 that are the same, like chlorine, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, we see that they can come together. Now, if we share this pair of electrons, we get Cl, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 around this chlorine, 8 around this chlorine. It's happy. So we call that Cl2. Hydrogens only have 1 electron, but they can share it just as easily. So we have H2. So really, when you've got the same element, they're both pulling on the electron equally, so we have equal sharing. So we call this equal sharing. This, unequal sharing. Unequal sharing means that we have a pole. So we call them polar. If we have equal sharing, we call them non-polar. So here we have a polar covalent bond. Means we're sharing, just not equally. And here we have a non-polar covalent bond. So, those are covalent bonds. Covalent bonds have either equal or unequal sharing. If the sharing's equal, they're polar. If they're unequal, they're nonpolar.